Hello everyone, my name is JSC, CSC, Section B, subject LAC. My topic is matrix inversion. In this section, we will learn how to find an inverse of square matrix if it exists and learn the definition of the identity matrix. Identity matrix. For multiplication, one is called the multiplication identity for real numbers. Since A, 1 equal to A. For example, 5 into 1 equal to 5. If a matrix is a square matrix, has same number of rows or columns, then all such matrices have an identity element for multiplication. Identity matrix. 2 into identity matrix and 3 into 3 identity matrix. Identity matrix is nothing but the diagonal elements are 1 and the rest of elements are 0. Identity matrix multiplication. AI equal to A. Verify the multiplication. We can also show that IA equal to A. And in general, AI equal to IA equal to A for all square matrix A. Inverse of a matrix. All real numbers, including 0, have a inverse. For example, 5 into 1 by 5 equal to 1. A into 1 by A is not equal to 1. Is equal to 1. Same, not all squares matrix also have matrix inverse. If the inverse of matrix A exists, we shall call it A inverse. Then A into A inverse equal to A inverse into A equal to I. This is simple procedure to find the inverse of a 2 by 2 matrix. This procedure only works for 2 by 2 case. For example, we will be used it to illustrate the procedure. Find the inverse of 2, 3, 1, 2. Ij equal to delta equal to difference of product of diagonal elements. Step 1. Determine whether or not the inverse actually exists. We will define Lj as 2 into 2 minus 1 into 3. 1j is difference of the product of diagonal elements of the matrix. In order for inverse of a 2 by 2 matrix to exist, jj cannot equal to 0. If happens jj to be 0, then we conclude that the inverse does not exist and we show to 11 calculations. In our case, Lj equal to 1. So we can proceed. Step 2. Reverse of the entries of main diagonal consisting of 2's. In the case, no apparent changes is noticed. Step 3. Reverse the signs of other diagonal entries 3 and 1. So they become -3 and -1. Divide each element of the matrix by which in the case is 1. So no apparent changes will be noticed. The inverse of matrix is then 2 minus 3 minus 1, 2. To verify that this is the inverse, we will multiply the original matrix by its inverse and hopefully obtain the 2 by 2 identity matrix. 2, 3, 1, 2 into 2 minus 3 minus 1, 2 is equal to -4 minus 3 minus 6 plus 6 minus 2 plus 2 minus 3 plus 4. That is 1, 0, 0, 1. It is identity matrix. We use a more general procedure to find the inverse of a 3 by 3 matrix. Problem. Find the inverse of the matrix. 1, 3, 1, minus 1, 3, 2, 1, 2, minus 2, minus 2, 1. Steps to find the inverse of a matrix, any matrix. Argument. This matrix with the 3 by 3 identity matrix use element rows operations. to transform the matrix on the left side of vertical line to 3 by 3 identity matrix. The row operation is used for entire row so that the matrix on the right hand side of the vertical line will also change. When the matrix on the left is transformed to the 3 by 3 matrix identity matrix, the matrix on the right of the vertical line is the inverse. Procedure. Here, the necessary row operations are: step 1. Get the 0 below 1 in the first column by multiplying 0, 1 by -2 and adding the result to row 2. Row 2 is replaced by this sum then. Step 2. Multiply R1 by 2, add result to R3 and replace R3 by that result. Step 3. Multiply row 2 by 1 by 3 to get a 1 in second row first position. You can see this. Step 4. Add R1 to R2 and replace R1 by that sum. Step 5. Multiply R2 by 4, add result to R3 and replace R3 by that sum. Step 6. Multiply R3 by 3 by 5 to get a 1 in the third row, third position. Step 7. Eliminate the 5 by 3 in the first row, third position by multiplying row 3 by -5 by 3 and adding result to row 1. Step 8. Eliminate the -4 by 3 in second row and third position by multiplying R3 by 4 by 3 and adding result to R. Step 9. You now have the identity matrix on the left and our goal is completed. The inverse matrix. The inverse matrix appears on the right side of the vertical line and is displayed below. Many calculators as well as computers have a software program that can calculate the inverse of a matrix quite easily. If you have access to a T183, consult the manual to determine how to find the inverse using a calculator. Here's a 3 by 5 matrix. 1 minus 1 minus 1, 6, 7, 4, 5, 5, 5, 2, 4, 3, minus 5, minus 5, minus 5. Let's review one property of solving equation involving real numbers. If ax equal to b, then x equal to a minus a by b. A similar property of matrix will be used to solve systems of linear equations. Many of the basic properties of matrix are similar to the properties of real numbers, with the expectation that matrix multiplication is not commutative. Solving a matrix equation. Give a n by n matrix A and an n into 1 column matrix B, and a third matrix denoted by x will solve the matrix equation. Ax equal to b for x. A inverse into ax equal to a inverse b. A inverse a into x equal to a inverse b. Njx equal to a by b. X equal to minus a inverse b. Reasons for each step. First, given note, since A is n by n matrix, x must be n into x, where p is natural number. Multiply on the left by A inverse, associate properties of matrix. Property of matrix inverse. Property of identity matrix. I is the n by n matrix since x is n by p. 6-1. Solution. Note, A inverse is on the left of B. The order cannot be reverse because matrix multiplication is not commutative. Example: use matrix inverse to solve the system below. X plus y plus 2z equal to 1. 2x plus y equal to 2. X plus 2y plus 2z equal to 3. Determine the matrix of coefficients A, matrix X containing the variables x, y, and z, and the column matrix B containing the number of right side of the equal sign. A equal to 1, 1, 2, 2, 1, 0, 1, 2, 2. X equal to x, x, y, z, B equal to 1, 2, 2. Continuation. Second step. Form the matrix equation Ax equal to B. Multiply the 3 by 3 matrix A by the 3 by 1 matrix X to verify that this multiplication produces the 3 by 3 system on the J1, 2, 2, 1, 0, 1, 2, 2. XYZ equal to 1, 2, 3. If the matrix A inverse exists, then solution is determined by multiplying A inverse by column matrix B. Since A inverse is 3 by 3 and B is 3 by 1, the resulting product will have dimensions 3 by 1 and will store the viva A and VP B. Inverse matrix can be determined by the methods of a previous section or by using a computer or calculator. The display is shown below. X equal to 1, 1, minus 1, 2, 2, 2, minus 1, 0, 1, and 1, 2, 3, 3 minus 1, 4, 4, 4. Solution. When the product of A inverse and matrix B is found, the result is as follows. X equal to minus A inverse S. The solution can be interpreted from the X matrix X equal to 0, Y equal to 2, and Z equal to minus 1 by 2. Written as an ordered triple of numbers, the solution is 0, 2, minus 1 by 2. Another example, using matrix techniques to solve a linear system. Solve the system below using the inverse of matrix. X plus 2y plus z equal to 1. 2x minus y plus 2z equal to 2. 3x plus y plus 3z equal to 4. The matrix is 1, 2, 1, 2 minus 1, 2, 3, 1, 3. The coefficient matrix X is displayed to the left. The inverse of A does not exist. We cannot use the technique by multiplying A inverse by matrix B to find the variables x, y, and z. Whenever the inverse of a matrix does not exist, we say that the matrix is singular. There are two cases where inverse method will not work. 1. If the coefficient matrix is singular. 2. If the numbers of variables is not the same as the number of equations. Application. Production scheduling. Labor and material costs for manufacturing two guitar models are given in table below. Suppose that is given week $1,800 is used for labor and $1,200 used for materials. How many of each model should be produced to use exactly each of these allocations? Guitar model A and B. Labor cost $30. Material cost $20. B. Labor cost $40. Material cost $30. Solution. Let A be the model of a guitar to produce and B represent the number of model B guitars. Then multiplying the labor cost for each guitar by number of guitars produced, we have 30x plus 40y equal to 1800. Since the material costs are 20 and 30 for model A and B respectively, we have 28 plus 30b equal 100. This gives the system of linear equations 30a plus 40b equal to 1800. 20a plus 30b equals 1200. We can write it as using the result x equal to a inverse b equal to a equal to 30 40 20 30. Produce 60 model A guitars and no model B guitars because a equal to 0.3 minus 0.4, b to minus 0.2, 0.3 into 1800, 1200. 0.3 into 1800 minus 0.4 into 1200 plus 0.2. Thank you.